Alright, so welcome back to part 2 of section 7.4. In part 1 we looked at the properties of logarithms and we also looked at expanding some of these expressions, okay? So in the first part of part 2 here, we are going to condense here, okay? So we're going to do the opposite. Instead of expanding, we're going to condense. Now, the thing about condensing is you always want to take care of the power property first. Alright, so this 8 needs to go back onto that x as an exponent, and this 9 needs to go back on that y as an exponent as well. Alright, so let's write out that part first. So we have ln of 12 plus ln of x to the 8th power minus ln of y to the 9th power. Alright, so again, first and foremost, always take care of your power property first when you are condensing. Alright, next part here. I see addition there, which means this is the product property. So we're going to rewrite that as one statement using multiplication. Alright, so we're going to get ln of 12 times x to the 8th power minus ln of y to the 9th, okay, because we haven't done anything with that yet, okay? So this is just going to move straight on down there. All right, last part here, I see subtraction, so that is the quotient property. All right, so I'm going to write this kind of over here on the right-hand side here, so I don't run into that next problem. All right, so we get ln of 12 times x to the 8th over y to the 9th. Now, that looks like my answer. However, I always want to make sure if there's any simplifying or reducing that can be completed, and it doesn't look like it. I mean, there's nothing attached to the y, in front of the y, to be able to reduce that 12. And then the variables are different, x and y. So this is my answer. Alright, let's go down here to the next one. Hox example number 5. Use the properties of logarithms to condense again. Okay, so we're still condensing here. Writing the answer as a single term with a coefficient of 1, all exponents must be positive. Okay, now, first thing I should do is, of course, take care of my power property. So that 3 needs to go there, that 7 needs to go there, and that 5 needs to go there. So we have 3 exponents to move this time. Alright, so let's go ahead and take care of that. Log of x cubed y squared to the 3rd power plus log 1 over x taken to the 7th power minus log of y to the 5th. Now if you notice, I went ahead and wrote that 5 inside the parentheses with y because that's the only thing that's there. Okay, it's just y, and so that 5 is going to attach itself as an exponent on to the y itself. However, on the first 2 terms, notice I kept the parentheses and I wrote the exponent on the outside. That is because I'm going to have to take a power to a power. And when we take a power to a power, we have to multiply our exponents, okay? So, over here on this first one, we see 3x cubed and y squared, but we're taking that to the 3rd power. So we can't forget to multiply those exponents. So we're going to get log of x to the 9th power, y to the 6th power. Okay? Again, all I'm doing is I'm multiplying my powers there. When we do a power to a power, the rule always states that I have to multiply those exponents, okay? So x cubed to the 3rd power is x to the 9th, and y squared to the 3rd power is y to the 6th. All right, plus, now we have to do the same one. Now this one's a little bit different because this is a fraction, okay? But what I have to remember on here is that I'm going to take the numerator to that power, and I'm also going to take the denominator to that power, okay? So we're going to do log. Now 1 to the 7th power, 1 to any power is always what number? And that would be 1. So 1 to the 7th power is like 1 to the 99th power. It doesn't matter how many times we multiply 1, we're always going to give it 1 as an answer. However, that bottom is going to be x to the 7th power. All right, minus log of y to the 5th, because we didn't do anything with that. All right, so be careful here. Make sure you take that 1 to the 7th, and then also make sure you take the x to the 7th power as well. Okay, the numerator and the denominator must be taken to that power. All right, now we need to work with a couple more of my properties here. Okay, so I see that addition there. That is the product property. So we have, and now we are multiplying by a fraction here, so it will come in handy to go ahead and put that over 1. So I can do numerator times numerator, denominator times denominator. All right, so we're going to combine that as log x to the 9th, y to the 6th, over x to the 7th, minus log y to the 5th. All right, now we only have one property left. I see subtraction. So that is the quotient property. All right, which means that y to the 5th is going to, let's see, it's going to be divided by, okay? So basically, let me write this out so that way you can kind of see it, okay? So we're doing x to the 9th, y to the 6th, over x to the 7th. And we're going to be dividing that by y to the 5th. Now, remember keep, change, flip. When we do keep, change, flip, we're going to change this to a multiplication statement, and we're going to flip this to 1 over y to the 5th, okay? Which means this y to the 5th is going to be part of the denominator now. All right, so let's write that right up here. Now we should be down to 1 log. So log of x to the 9th, y to the 6th, over x to the 7th, y to the 5th. All right, now we're not quite finished there because there is some simplifying. Remember in the last example, I mentioned that you always have to make sure that you look at these carefully and see if there's any simplifying that can be completed here, okay? I see x's both on the top and the bottom, in the numerator and the denominator, and I also see y's, okay, in the numerator and denominator. Now, when we divide exponents, as long as they have the same base, okay, or the same variable in this case, okay, what do we do with those exponents when we are dividing them? The answer is we are going to subtract them, okay? So here we're going to do 9 minus 7, and on the y's we're going to do 6 minus 5. Now, keep in mind, order does matter there. It's always the numerator exponent minus the denominator exponent, okay? So very important there. All right, so let's simplify this. So we get log of x, 9 minus 7 is 2, so x squared, and y, 6 minus 5 is 1, so it'd just be 1y, and that is my answer. Log of x squared times y. All right, example number 6. Now we start getting into evaluating some logarithmic expressions, okay? Now, these are quite different than the ones we did in 7.3. In 7.3, we set these equal to x, changed them back to an exponential equation, and then solve them. In this case, you cannot. You cannot do this, okay? So we have to do what is called the change of base. Change of base formula. All right, so change of base formula, and I just wrote through that. There we go. Cleared it. There we go. Change of base formula says if I have log base b of a, okay, and I cannot convert that back to an exponential to solve it, then what we can do is take the log of A and divide that by the log of B. Okay, and then that will give me my answer. All right, this is called the change of base formula, and you can even do it on the ones that you can change to an exponential. However, changing them to an exponential, you have to know how to do that, of course, and that's much easier than having to do this every time, okay? But I have had students in the past that have used change of base formula for every single one. All right, so my base here is 15. This is log base of 15 of 504, okay? We're going to convert this to log of 504 over log of 15. All right, now I'm just going to grab our calculator here. Now the reason why we use log, because that's common log, so you can just use your calculator, so you can hit log and then type in 504. And I'm going to go ahead and write down every decimal place that I see. 2.702.430.536 over log of 15, which is 1.17609.1259. Okay, and so all we have left here is to divide those two numbers. Numerator divided by denominator. And it says we can round our answer to 2 decimal places. So I got 2.30. Really came out to 2.297, but that 7 tells me to go up. Okay, so 2.30. Now I would strongly recommend to not round until you get to your final answer. If you round early, it could throw off your answer. Okay, so be really careful here, okay? Make sure, do not round until your final answer, please. All right, Hawks example number 7. Same thing. Now notice my base here is a fraction. Okay, don't be thrown off by that. Your base can sometimes be a fraction. Okay, now don't forget, base is always on the bottom. Okay, so back up here again, base is always on the bottom. Base is on the bottom. Base starts with the letter B. That also is the first letter in bottom. Base on the bottom, base on the bottom, base on the bottom, base on the bottom. Okay, so log of 989 over log of 1/9. All right. Again, turning my calculator here. Log 989 gives me 2.99519.6292. All over log of 1/9, and that gives me a negative value, negative 0.9542425.094. I paused there just for a minute because I was making sure that I didn't skip a digit or anything like that, okay? All right, so numerator divided by denominator gives me, and I can round this to 2 decimal places because that's what the directions tell me to, so negative 3.14. All right, so again, I would not round until you get to your final answer, okay? So use as many decimal places as possible, just to be on the safe side, to make sure that you are going to get the correct answer, the correct result there. All right, now, one more thing I want to point out to you real quick before I sign off for this video is I want to give you a couple of tips here, okay? So when we expand, when you expand, use the power property last. Okay? Very important. Use it last. Okay? But when you condense, use the power property first. Okay? Extremely important. I see so many students that get the exponent in the wrong spot. Okay? So very important here. Make sure when you expand, use that power property last, and when you condense, use the power property first. You won't go wrong with your exponent if you follow those rules.